The devastating impact of Super Typhoon Ragasa has left a trail of destruction in its path, affecting the lives of many. With its ferocious winds and heavy rains, it has caused immense loss and suffering in Hong Kong, Guangdong, and Taiwan. The alarming frequency of such storms serves as a stark reminder of the looming threat of climate change. As we grapple with the aftermath of this powerful typhoon, we must come together and acknowledge the urgent need for action. The well being of our planet and the safety of future generations depend on our collective response to these pressing issues. Indifference to the signs of climate change is no longer an option. The time to act is now. This is called to protect our environment and to safeguard the vulnerable communities at risk. Let us stand in solidarity and work towards a sustainable future for all. Earlier this month, Ragasa formed over Micronesia in the Western Pacific and quickly gained strength as it moved over unusually warm ocean waters. By Monday, it was officially classified as a super typhoon, boasting maximum sustained winds of 265 kilometers per hour. Ragasa wreaked havoc in parts of Taiwan and the Philippines. In living country Taiwan, the typhoon caused a barrier lake to overflow, flooding nearby Guangdong township with a torrent of water. The aftermath was a mess of mud and rocks everywhere, while some part of the flooding has receded. Geologists liken the breach to a tsunami coming down from the mountains, as around 15.4 million tons of water, equivalent to about 6,000 Olympic-sized swimming pools, were unleashed when the dam broke. In China, Ragasa, dubbed the king of storms, forced nearly 1.9 million people to evacuate in southern Guangdong province. Schools, factories, and transportation services were shut down across about a dozen cities. In Hong Kong, the typhoon left at least 80 people injured as its powerful winds toppled hundreds of trees. Ragasa, equivalent to Category 5 hurricane, is the strongest storm in the world this year and has been tearing through the South China Sea for days. Typhoons are becoming increasingly powerful due to rising ocean temperatures, a direct result of climate change. According to United Nations Environment Program, average temperatures in the Pacific Ocean have increased by approximately 1.5 degrees Celsius over the past century. Typhoons serve a critical function on Earth by dissipating heat. The greater the heat in the ocean, the more tropical cyclones are generated to remove that heat. The Earth maintains a delicate balance, and warming oceans will lead to more intense typhoons. Research from NASA's Goddard Institute for Space Studies indicates that when the Earth experienced similar climatic conditions over 1 lakh years ago, fluctuations in ocean temperatures resulted in the formation of more superstorms. The melting of ice sheets created a freshwater lens over the oceans, which caused them to retain additional heat. Further accelerating ice sheet melting, this influx of fresh water disrupted two key ocean currents, leading to significant global temperature disparities that fueled the development of these superstorms. The eye wall of a hurricane or typhoon is its most perilous component, and as this intensified, Typhoon Ragasa was classified as a super typhoon. Its strength reached the equivalent of a Category 5 hurricane. The highest classification for Atlantic hurricanes are capable of producing wind speeds exceeding 250 kilometers per hour. Following the impact of the Super Typhoon Ragasa, Hong Kong faced significant destructions, with the city paralyzed for 2 days. Authorities are working diligently to clear approximately 1,200 fallen trees and addresses a backlog of 1,000 flights that affected around 140,000 passengers. The forecast for Typhoon Ragasa indicates heavy to very heavy rainfall across Thailand from September 24 to 26, with an increased risk of flash floods and runoff on September 25th. Coastal areas in 2024, the global average carbon dioxide reached a new record high of 422.7 parts per million, indicating a concerning trend in atmospheric composition. To better understand the factors contributing to this increase, researchers utilize extensive pre-industrial climate simulations and historical data driven by natural forcing agents such as volcanic and solar influences. Additionally, the use of paleoclimate proxies provides valuable insights into the uniqueness of current climate variability and change compared to pre-industrial patterns, although their application is limited to specific regions. Over the past 60 years, the rate of atmospheric carbon dioxide increase has been approximately 100 times faster than natural increases. Observed at the end of the last ice age, 11,000 to 17,000 years ago. This rapid accumulation of carbon dioxide has led to a 30% increase in ocean acidity, as the ocean has absorbed enough carbon dioxide to lower its pH by 0.1 units. It is crucial for everyone to be aware of these developments and their implications for the environment and society as a whole.